Sanitation Elect to all the class 12 students, and today we will be discussing the last topic of the chapter applications of derivative, okay, which is approximation. In this topic, we are going to see how we will apply derivatives to approximate certain values, like for example square root of 36.1, okay, square root of 25.4, like that. So when you are finding out the square root of integers, okay, positive integers, then we had seen a few methods for finding out finding out the square roots in lower classes. But when you are finding out the square root of some decimal numbers, then using those methods are a little bit difficult. So therefore, here in this topic we will see how we can apply derivative to approximate such values, okay, and that will be easier as compared to the usual methods which you were doing in lower classes. So here in this topic we will be approximating the values. Approximate means we are not getting the exact value, but we are finding the approximate values of square root of some decimal numbers, okay. So we will see first how the derivative is to be used for approximating such values, okay. So now till now we had considered a function as y is equals to fx, which means we are always taking a function in terms of x and y, where we consider x as the independent variable and y as the dependent variable. So whenever you make some changes on x, okay, so there will be obviously a corresponding change on y, because y is depending on x. So when you make some changes on x, y will also change. So first you note down this thing. Delta x is the notation which we use to denote the change in variable x, and delta y is the notation we used to denote the change in y, okay. So when you make some changes on x, there will be a corresponding change on y. So the changes you make on x is denoted by delta x, and the corresponding change on y is denoted by delta y, okay. Now my original function is y is equals to f of x, okay. So now if I make some changes on x, so instead of x, when your variable is x, then you denote it by y. So now if instead of x, if I change it to x plus delta x, okay, then you won't get the same y, then you won't get the same equation, because when your variable is x, then you denote it by y. But here in this case, I had denoted my variable as x plus delta x. I had made some changes on x, so therefore you will get a corresponding change on y. So that change you can write it as delta y, okay. So your original function is this, where your independent variable is x. Since you are changing x to x plus delta x, there will be a corresponding change on y, so that change is denoted by delta y, okay. Now here I'm interested in finding out, when you change x, when you are putting some changes on x, then what will be the corresponding change on y, which is denoted by delta y. So here I'm interested in finding out delta y. So therefore I will express delta y as f of x plus delta x, okay. You take this y on the right hand side, so that will be minus y, okay. So I can write delta y is equals to f of x plus delta x minus, now y I can write it as f of x, right. So it is same, okay. So I'm trying to express everything in terms of f, okay. So now what I'm going to do is, for this expression, okay, so since I need to apply derivative in this particular topic, so therefore I'll try to bring it in terms of derivative, okay. So therefore I can write this as, now for this expression I will multiply and divide this expression with delta x, okay. So later I will tell you why am I doing this, okay. So this is my original expression, so on that I'm going to multiply and divide with delta x. Now delta x will get cancelled. So the original expression, I'm not changing anything. Okay, so just I'm multiplying and dividing it with delta x so that I can express this in terms of derivative. Okay, now using first principle method, okay, in first principle method, you have this f dash x is equals to limit of f of, you may remember this, okay, divided by h as h tends to 0. Okay, so this was the first principle method you had been introduced in class 11 when you were first introduced with the topic of derivative. Okay, so we have this f dash x is equals to limit of f of x plus h minus f of x upon h as h tends to 0, right? So now this is same here. Okay, instead of h I taken here delta x, otherwise it's all same. So therefore now when I delta y is equals to this, and I here multiplied and divided by delta x such that delta x is the smallest possible, not smaller, nearest to 0. Okay, so for that I can use the concept of limit. So therefore I can write limit of f of x plus delta x minus f of x as delta x tends to 0 into delta x, right? Okay, now this is nothing but it is f dash x using the first principle method. So you can write delta y is equals to, now this whole thing is f dash x, right? Okay, into delta x. Okay, so if you know f of x, okay, and delta x, then you can find the corresponding change in y directly by using the derivative. So f dash x, so the change on y, corresponding change on y is, now this is approximation. So here instead of equal to sign, you can use approximate sign. Okay, so here delta y is equals to f dash x into delta x. So this is how we can find the corresponding change on y using first principle, derivative, using the first principle concept and derivative. So we get delta y is equals to this. Now this is the only thing you have to remember under this topic. Okay, so we know that this one thing you have to remember, that is when your original function is this, and when you are changing x to x plus delta x, then this is the corresponding change on y, and this delta y, whatever the change we get on y, delta y, so delta y is equals to f dash of x into delta x. So this is how we can now here for finding out the corresponding change on y, we are applying here derivative. Okay, so only this three things you have to remember. Your original function you had expressed as y is equals to f of x, and this is the corresponding change you are making on x. So y plus delta y is equals to, so this is the corresponding change, delta y is equals to f dash of x into delta x. Okay, so this, only this part you have to remember. Okay, now all these derivations you don't have to mug up, you just understand how we come to this equation. Okay, so this only thing matters in this topic. Now I will take a few examples to let you know how these questions are to be solved, or how the values, square root of certain decimal numbers are to be approximated using derivatives. So I'll show you a few examples. Now let's look at this first example. You are asked to approximate the value of square root of 36.1. Okay, so to evaluate this value, you know the long division method which we used in the lower classes to get the square root of any values. Okay, but since this is a decimal number, so that will be that method will be a little bit difficult. So it's easier for us to evaluate or approximate such values using derivative. Okay, so this is how it is to be done. So first of all, we need all these things: x, delta y, y. Okay, so out of this given value, so you have to first choose what will be your x and what will be your delta x. Okay, and what is your y. So then we have to evaluate delta y. Okay, So now whatever your given function is, so it's a square root. So first of all you will write, take fx is equals to square root of x. This is first thing you have to remember. So whatever your function is given as, okay, here in this case we are asked to evaluate square root of. Also you may be asked to find out the cube root of certain values. So if it is a square root function, then you will write f of x is equals to square root of x. However the function is defined in that particular way, you have to take f of x. Okay, if you're asked to find out the cube root of certain values, then your f of x will be cube root of x, right? So whatever the function is given, in that way you have to take f of x. Then after this, after defining what will be your function, then you have to suppose x and delta x. Now f of x means y, we already got this, right? Now you have to substitute x and delta x. Okay, now you will write, now you look at this value 36.1. so 36.1, okay, and your function is square root of x. Now you have to think of that perfect square number which is for which whatever your delta x will be, that will be closest or nearest to 0. Okay, so when I write 36.1, so can you think of a perfect square number which is nearest to 36.1? So we have 36. Okay, so 36 is a perfect square number, 6 are 36. And after that you have 49, right? So you have two square numbers. Okay, in between you have 36.1. One is 36 and the other is 49, right? So now when I take let x is equals to 36, you have two options. Either you can take x is equals to 36 or you can take x is equals to 49, or okay, you have these two options. Now you have to take delta x, let x is equals to this and delta x, such that when you take when you add these two, it should be 36.1. so when your x is 36, your delta x is 0.1. okay, so x plus delta x is 36.1. so 36 plus 0.1 is 36.1. Now when you choose x is equals to 49, then what will be your delta x? So that will be negative, now you have to take this, right? Okay, 49 minus 36.1. okay, so that will be 9 okay, 8 2, so that will be negative 2.9, is it? Okay, sorry, negative 12.9. okay, so that length that this value is very much far away from 0. So you look here, your ideal this selection of x and delta x is such that delta x is nearest to 0. That is the that should be your selection of x and delta x. okay, so you have to choose x such that corresponding to which you will get one delta x, so that has to be possible nearest to 0. So you can look here now, this is 0.1 and this is negative 12.9. okay, which one is nearer to 0? So obviously this one is nearer to 0, so therefore your x and delta x should be 36 and 0.1. you will not choose this one. okay, so this is the first and second step. So in first step you have to define your function in however this function is given. If it is given in a square root function, then you will write f of x is square root of x. If your function is cube root, then you will write f of x is cube root of x. okay, this is first step. Second is you have to then define what is x and delta x such that delta x is nearest to 0. In all, out of all the possible pair of x and delta x, you have to choose that pair for which delta x is nearest to 0. So that is your ideal choice. And after this, okay, now we have got x, we have got delta x, we have got y. Y means f of x. Now you have to find out delta y. okay, so now we have to find out square root of 36.1, that is square root of 36 plus 0.1. You don't have to write this every time. It's since we are doing it for the first time, therefore I'm writing it. Square root of 36.1 is 36 plus 0.1. So that is So this is f of x plus delta x, is it? So this is f of x is x, the square root of x. So square root of 36 means it is x plus 0.1 is f of x plus delta x. So this is you have this y plus delta y. In the previous section we had defined this, right? So you only remember this part. So square root of 36.1 is y plus delta y, right? So y means f of x, okay? So or you can write f of x plus delta x. Now what is f of x? X is 36. So square root of 36 is 6. So we have 6 plus delta y. Is that clear? So this is what we have to find out. So we have to find out delta y. Is that clear? Okay. So this part, it may be a little bit confusing to you. So therefore, please check this part 2 or 3 times until and unless you are clear with this concept. It's very simple. Okay. So therefore, you go through this part 2 or 3 times, right? So now we got this square root of 36.1 is 6 plus delta y. Now we have to find out delta y, and we know that delta y is equals to f dash x into delta x. We know this, right? So my fx is equals to square root of x, okay? So directly I can write what is f dash of x, so that will be 1 upon 2 square root of x. Since my fx is square root of x, so f dash x is 1 upon 2 square root of x into delta x. What is your delta x? That is 0.1, okay? So this is equals to 1 upon 2 square root of x is 36. X is 36, so that is 2 into 6, okay, into 0.1. So that is 0.1 divided by 12. Now you have to evaluate this value, okay? So 0.1 divided by 12. So see how you can solve this. So you can write this as 1 divided by 120, okay? So now you solve this and see what you get. So that will be 0.0 okay, so okay, 0.0. So you can write this like this. If you are not understanding it, you can write 1. So you put point, you get 10, right? And then you get 10. Then you put again 10, so you get 0. So then now you can solve it. 120 into 8, so it is 16, 1, 9. So that will be 0.008, right? So that is 960. Okay, so that is 40 and so on. So we get this. So this is equals to 0.008, right? So now we have square root of 36.1 is equals to 6 plus delta y, and delta y is equals to 0.008. Okay, so square root of 36.1 is equals to 6.008. So this is how you can find out the values of or you can approximate such values, square root of certain decimal numbers. Okay, so this is how it is to be done. We will take one more example. Actually, if you understand this, it's very simple. Okay, only 2 or 3 steps are to be remember how it is to be done, and otherwise everything is same. So if I change the question to approximate 0.009 cube root. Okay, now if I ask you to approximate cube root of 0.009, so first of all you have to define the function, and my function is given as cube root. So therefore you will write f of x is equals to cube root of x. Okay, in the previous example your function was square root, so therefore we had written f of x is equals to square root of x, and here my function is cube root, so therefore you will write f of x is equals to cube root of x. So this is how it is to be the function is to be defined. then you have to choose x and delta x, okay, such that delta x is nearest to 0, okay. Now 0.009, when I take this, so 0.009, so you may think of choosing x is equals to 1, okay. Some of you may think choosing x as 0.008, because 0.008 cube root of 0.008 is 0.2, right? So you can do that. So if you choose x is equals to 1, okay, so then it is 1.000, so that is 0.009, so 100, okay, 99, okay, so 0 point this. So if you choose x is equals to 1, okay, then your delta x is equals to negative 0.991, okay. And if you choose x is equals to 0.008, because it's a perfect cube number, okay, so if you choose x is equals to 0.008, then your delta x is equals to 0.001, okay. Now you look at these two values, 0.001 and negative 0.991. Now you think of plotting these 2 points on the number line and you compare which one of them will be nearer to 0, okay. So obviously this will be nearer to 0, so therefore this will be your choice of x and delta x. You will not choose this, okay. So as you choose delta x nearer to 0, you will get a better approximation for such values, right? So therefore if you choose this, even though you will get an answer, but that will be not an approximate value for the cube root of 0.009. So you have to get a better approximation, you have to choose delta x such that it is nearest to 0, right? Okay. Now you have to find out delta y. Now it's quite same, okay. So that is 0.009 cube root. This is equals to, you will write this, okay, what is the cube root of this? So that is 0.2 plus delta y, okay. So every time you will write this. So this is what we have to find out, okay. So this is 0.009 means it is x plus delta x cube root. So that is equals to f of x plus delta y, y plus delta y. So y means cube root of x, okay. So that is cube root of this is 0.2 plus delta y. Directly you can write this, okay. So we have to now find out delta y. So we have delta y is equals to f dash x into delta x, right? So f dash x is equals to 1 upon 3 x raised to 1 upon 3 minus y. So okay, into delta x. So this is equals to 1 upon 3, okay. So this will be x raised to negative 2 by 3. So I will bring it down. So that will be x raised to 2 by 3. So here you will get negative 2 by 3. So I will bring it down in the denominator to make the exponent positive, okay. Into what is my delta x? It is 0.001, okay. So now this is equals to 1 upon 3, okay. What is my x? X is 0.008 raised to 2 by 3 into 0.001, okay. Now some of you may face problem in solving such values, okay. So that is quite simple using the law of exponent. So this I can write it as delta y is equals to 1 upon 3 into, okay. So first, since this is a cube number, okay, I will separate this as 2 into 1 upon 3. So 1 upon 3 I will bring it inside. So I will write 0.008 raised to 1 upon 3 into 2. I can do that using the law of exponent, right? So you have this. If you have x raised to m into n, so that is x raised to mn, okay. So that will be 0.008 raised to 1 upon 3 into 2. So that will be 2 upon 3, okay. Since we can find its cube root, so therefore I'm taking cube root together with 0.008, right, into that is 0.001. So this is equals to 1 upon 3 into, so cube root of 0.008 is 0.2. Okay, this is done, raised to 2 into 0.001. So this is equals to 1 upon 3 into 0.04, right, into 0.001. So that is 1 upon 0.12 into 0.001. Now you solve this, and whatever value you will get, you will put it here, and you will get the approximate value of 0.009, cube root of 0.009. Okay, so this is how these questions are to be done. It is quite simple. Step number 1, I will repeat it. Step number 1, whatever the function you are asked to approximate, cube root, square root, okay, so in that way you will define your function. If it is to find the square root of, then you will write f of x is equals to square root of x. If you are asked to approximate cube root of certain value, then you will write f of x is equals to cube root of x. So whatever the function is defined, whatever the values you need to approximate, in that same function you will define your f of x. That is step 1. Okay, in second step you have to choose x and delta x corresponding to that function such that delta x is nearest to 0. So that is second thing you have to remember. And then third step you will write this your function. Okay, so f of x plus delta x is equals to y plus delta y. So y means f of x, so you can find out directly this plus delta y. So then you will evaluate delta y using the derivative, and then you will put it back in the star, which gives you the approximate values of cube root of 0.009. So all such questions are to be done in this way. The main thing you have to remember is when you are asked to find out, okay, the any value of cube, whether it is cube root or square root, you have to define your function in that way only. And the most important thing is selection of x and delta x. It should be selected in such a way that delta x is nearest to 0. Okay, so this is the first type of questions from the topic approximation. Okay, now we will see one more type of example. This is the second type of question. It may be asked from the topic approximation. Okay, so it's quite simple. Find the approximate change. Now here you are only asked to find out the approximate change, which means delta y. Okay, only you have to find delta y. You don't have to put it back in the star which we had taken in previous two examples. Okay, so find the approximate change in the volume V. Okay, now here your function is given as V. Volume, it is already defined as V, so you will not take your variable as y. Instead you will take V, since it is defined in the question. Okay, okay, find the approximate change in the volume V of a cube of side x meters. So you have a cube whose side is x. Okay, so now it's obvious, when you increase the side, volume will increase. You will when you decrease the side of the cube, volume of the cube will also decrease. So volume is depending on x, so V is in terms of x instead of y. Now here you will take V. Okay, so you have to find delta V. Okay, you have to find the approximate change in the volume V of a cube of side x meter caused by increasing the side. X is changed, or x is increased by 2%. Okay, so you will write it in this way. So delta x, that is the corresponding change on side, is 2%. Okay, side 2% x, 2% of the side. Okay, so that is 0.02 x. So this is delta x. Now we know that delta V, okay, and you have this relation, V is equals to x cube. Volume of a cube is x cube, so V is equals to x cube, and we know that delta V is equals to dV by dx. F dash, we used to write f dash x, so that is dV by dx into delta x. Okay, so dV by dx means it is 3x square into delta x, that is 0.02 x. So this is equals to 0.06 x cube. So this is the approximate change in the volume. Okay, when there is a corresponding change on the side and it's being increased by 2% of this side. Okay, so this is how it is to be done. So when you are asked to find out the approximate change, then you only have to find out delta y. What will be the corresponding change on the function when there is a corresponding change, when there is a change on the variable x. Okay, so this is what you are asked to find out. Okay, so if you are very much clear with the concept, and also if you understand the question in a correct way, then it's very easy for us to solve, and for that you need to do a lot of practice. Okay, so today to understand or to clarify the concept of this topic approximation, you will do exercise 6.4. okay, so now in this exercise you will find the questions which are to approximate the values of certain functions, right? Cube root, square root, and so on, and then to find the approximate change related to some mensuration problems. Okay, so these are the two types of question which may be asked from this topic, right? And with this we had completed this chapter, application of derivative, and also we had now completed the part of derivative. Okay, so in chapter 5 we had thoroughly discussed how the different types of functions are to be differentiated, right? And that is you were taught all the different ways of differentiating different types of function. And in this chapter we had seen the application of derivatives. So we had seen the application of derivative in the field of finding the rate of change of certain quantities which are related to the mensuration. Okay, also we can apply derivative in approximating such values. Okay, also we can apply derivative in finding the equations of tangent and normal, and we can also apply the derivative to find the point of local maxima and minima. And in optimization problems also we can apply derivative to find intervals in which the function is strictly increasing or decreasing. Okay, so these are all the fields where we can apply derivatives. So we had thoroughly discussed all these topics, and I hope you understood all these topics very clearly, right? So with this we had completed the part of derivative, and now in the next chapter we are going to see integration, which is totally a new topic, and but not actually a new topic because you might be using that in physics. Okay, but in maths it will be a new topic which I'm going to introduce in the next class. Okay, that is integration. So till then, take care and stay safe. Thank you.